Okay, so here we have a model that represents how sound travels through the ear. So first it starts with the pinna, which is the part of the ear that you can see and you can touch, which collects as many sound waves as possible and channels them into the auditory canal. The sound travels through the auditory canal into the eardrum, and as the air vibrates through, the eardrum vibrates. And then as the eardrum vibrates, the ossicles vibrate, which are the three smallest parts of the three smallest bones of the human body. The pressure of the sound waves increase as they travel through the ear. The volume decreases, which is going to increase the pressure. And you have to increase the pressure so that the vibrations are transported into a liquid. They go into the cochlea where they are interpreted and transported into like electrical signals. And the cochlea contains a liquid which also vibrates, so that's why they have to be transported into a liquid. Inside the cochlea, there's specialized cells that turn vibrations into the electrical signals, and then they're sent through the nerves to the brain where they're then interpreted and integrated as sound. So here we have a demonstration of sound being captured by the pinna, traveled through, and it vibrates down here. I don't know if you could see, but the water did vibrate. And the ossicles were vibrating, and it was sent through. And yeah. And here's a more in-depth version of the auditory canal. So first we start with the pinna, which is the ear. It's the part that you can see and you can touch. It's the collector of sounds that are then taken to be processed at deeper levels. Its structure is provided by cartilage. Then we have the helix and the antihelix. The helix and the antihelix. The helix is like the round shape of the distal borders of the pinna. The antihelix is anterior to the helix, and it marks the entrance to the concha. The concha is the entrance to the ear canal. The external auditory meatus and the concha are resonating cavities that both contribute to hearing and are a major determinant of resonant frequency. Then we have the tragus. It is a epithelium-covered cartilage. It's like a flap, and it looks like it could cover the entrance to the meatus. Then we have the external auditory meatus, which is 7 millimeters in diameter and 2.5 centimeters in length. It's lined with hairs and cerumen, which is earwax that helps to trap insects and dirt, which protects the tympanic membrane. Then we have the tympanic membrane, which is known as also known as the eardrum. It's the boundary between the outer and the middle ear. It's 3 layers of tissue. The outer layer is a continuum of the epithelium from the external auditory meatus and the pinna, and then the inner layer is a continuum of the mucosa of the middle ear. The tympanic membrane is at a 55-degree angle with the floor. Then we have the eustachian tube opening, which connects the middle ear with the sinus cavity. It helps to balance the pressure in the middle ear, which is like your ears popping. And it also helps to drain fluid from the middle ear. And then we have the cochlea, which is a sensor for balance and also a sensory organ of hearing. It's spiral and fluid filled. The cochlear duct is filled with liquid, and the liquid's called the endolymph. Sound waves are transduced into electrical impulses, and the spiral configuration allows for different frequencies to be stimulated, and on different locations, different frequencies are perceived. So specific areas along the cochlea are stimulated by vibrations that are carried in through the fluid of the endolymph in the cochlear duct, and then the vibrations are then converted to electrical impulses in the cochlear duct, and through mechanical stimulation of the hair cells in the organ of corti, the vestibular cochlear nerve then carries those impulses to the brain's auditory cortex, which then interprets all of it. We also have the ossicles, which are the 3 smallest bones of the body: the malleus, the incus, and the stapes. As the eardrum vibrates, the ossicles vibrate, and the 3 bones are on an axis. And then the vibrations produced by the stapes go into the cochlea. We also have some muscles of the auditory canal. One is the tensor tympani, which is 25 millimeters in length, and it arises from the interior wall of the middle ear space. Contraction of the tensor tympani pulls the malleus anterior medially, reducing the range of movement of the tympanic membrane, and by placing indirect tension on it. Both the tensor tympani and the stapedius, which is the other muscle of the auditory system, they work together to stiffen the middle ear transmission system, which reduces the transmission of acoustical information in the lower frequencies. And then contraction of the muscles reduces the strength of the signal that reaches the cochlea, which can help protect it from high signal intensities. And then the stapedius muscle is 6 millimeters long, and it's embedded of the posterior wall of the middle ear. Its only tendon emerges from the pyramidal eminence in the middle ear space, and it inserts into the posterior neck of the stapes, and when it contracts, the stapes rotate posteriorly. There are also some nerves that work with the auditory system. One is the facial nerve, which innervates the tensor tympani via the optic ganglion, and the stapedial branch innervates the stapedius. It extends from the base of the skull and goes through the temporal bone. And then we also have the auditory nerve, which sends vibrations and signals to the brain. It's located in the inner ear behind the cochlea and connects to the semicircular canals and the vestibular organ. So we already went through the process of sound going through, starting at the outer ear. But the inner ear houses sensors for balance, which is the vestibular system and the cochlea. The inner ear is made up of liquid, and vibrations need to be transported into a liquid, and that's done by having high pressures. When you have a low pitch, it's a slower vibration, and then a lower volume is a less dramatic vibration. The inner ear converts the sound that is now in liquid to an electrical code, and then the vestibular cochlear nerve and the brainstem pathways transmit the sound. The most important function of the middle ear is to transform the high volume, low pressure vibration from the tympanic membrane into high pressure with low volume at the stapes, because the stapes are so small, it's going to be a low volume, which is going to increase the pressure. The organ of Corti is on the basilar membrane, and as it vibrates, the organ is stimulated and sends signals to the brain via the nerves. As always, there are impairments that can occur in the auditory system. One is tinnitus. I wanted to talk about tinnitus because my dad has tinnitus, actually. He is a sheet metal worker. He's been working with loud construction machinery since he was like 17, so probably like 40 years now, I'd say. Tinnitus is ringing in one or both ears, and then like the ringing and the noise that you can hear is not caused by an external sound. It's all internally caused by like some sort of underlying problem. It can be from hear loss or an ear infection or a canal blockage. Even from like head or neck injuries. Certain medications can give you tinnitus, and also just exposure to loud sounds. It can be like a ringing, it can be a rhythmic pulsing or like a whooshing sound, which is in time with your heartbeat. Tinnitus can have negative effects on someone, such as fatigue, stress, sleep problems. It can cause like headaches or memory issues. I know my dad has a lot of problems sleeping because he constantly is hearing this ringing. I don't think that there's anything you can really do for it. There might be some things that can help lessen the symptoms and the side effects, but there's nothing that I know of or that he's been told that can directly stop the ringing. Another impairment is mastoiditis, which is an infection of the mastoid process. It starts as a middle ear infection and develops when it's left untreated. There are two kinds, chronic and acute. So chronic is when it lasts longer than a month and it comes back after antibiotics, and then acute typically goes away after treatment such as antibiotics and does not come back. It's more typical in children that are like 2 years and younger. Symptoms can be pain like on the ear or behind the ear, and it being like red and swollen. You can have a fever or pus flowing out of the ear. You can also present with hearing loss. A tympanoplasty can be performed to get rid of the mastoiditis, or a mastoidectomy, which is removal of the infected part of the mastoid bone.